what we're going to do is we're going to kind of work on a coordinate plane, but we're also going to use a graphing calculator to identify different types of polygons. Remember some vocabulary words here: scalene, Scaling means that none of the sides of the triangle are congruent. Remember that isosceles, two sides are congruent. And then, of course, equilateral, you can kind of see the word equal. That means the three sides are congruent. So in order for us to identify the type of triangle that we have here, we got to find the distance. So remember, this is on a coordinate plane. We know that C is going to be 7, 0. We know that B is going to be 4, 4. And we know that A is going to be 0, 1. So we're going to use the distance formula to figure out the measurement of each segment. So we did this first semester, so we have AB is equal to the square root. And we're going to start with the y values, parentheses, 4 minus 1 squared plus 4 minus 0 squared. Now, if you don't remember the distance formula, remember that the distance formula can be found by finding the square roots. And I like to start with the y's, y2 minus y1 squared plus x2 minus x1 squared. And remember, each subscript means it's a point for each point. I'm going to use the calculator here. So we're going to go to Control on, and I'm going to go ahead and press New. And I'm not going to do a graph. I'm going to use a calculator. Second x squared, you see you see the square root, and then you have 4 minus 1 squared plus parentheses 4 minus 0 squared, and then you want to get out of the square root, so you kind of move the cursor, press enter, and you notice you got 5. So the distance from A to B is 5. All right. So now I'm going to find the distance from B to C. Square root, we have parentheses 0 minus 4 squared plus 7 minus 3 squared. So let me go back and type into the calculator, second x squared, that's going to be the square root, parentheses 0 minus 4 squared plus parentheses 7 minus 3 squared, and then you press enter, and you notice we get 4 square root of 2. Let's double check that. 0 minus 4 squared, and we have 7. Oh, here's my mistake. 7 minus 4. 7 minus 4. So I had a mistake here, so this should have been 4. So let me see if I can go back. Control enter. No, enter. Okay, I'm gonna have to rewrite it. So second x squared. Second x squared. So we have parentheses 0 minus 4 squared plus parentheses 7 minus 4 squared. Enter. Gives me 5. And what we're going to do is we're going to find the distance from A to C. The square root. So it's 0 minus 1 squared plus 7 minus 0 squared. And so we're going to write into the calculator square roots, parentheses, 0 minus 1 squared plus parentheses 7 minus 0 squared, and that gives you 5 square root of 2. Okay. So we notice that these two sides are congruent, so we're going to say that this triangle is isosceles. Okay. For the next example, I'm going to use the graphing calculator. It's a much easier approach. You still have to do some math, but you can see it. It's sort of a hands-on approach. So I'm going to go to Control, On, and I'm going to go to the Geometry tab or the application. And here is the Geometry application. I'm going to go to Menu, View. You want to see the graph. Also, if you go to Menu, View, you want to see the grid, the dot grid. Okay, so I'm going to kind of escape here. Menu, Settings, I would just say auto, dot, degree, I want to be fixed at 0. Okay. Yeah, put fixed at 0. And let's go ahead and construct this triangle. We're going to go to Menu, Geometry, Shape, and we're going to go ahead and construct a triangle. So here is the grid, and we're going to go ahead and construct or plot the point 0, 0. 1, 1, 2, 3, 4. So that's my second point. And then we have 5, 1, 2, 3, 4, 5, and then go up 2. Make sure you do this correctly. 1, 2, 3, 4, 5, and then up 2. Now, what I want you to do is I want you to make sure that you label your triangle. So go to Geometry, Actions, Text, and you're going to go to the point, and this was point D. You're going to go to this point, and that was E. You're going to go to this point, if you can, and that's going to be F. So there's our triangle. We have triangle DEF, and if you want to measure, this triangle or the sides of the triangle, you're going to go to Menu, Geometry, Measurement, Length. So you want to measure the length from this point to this point, and what do you get? You get 4 units, and that's why you wanted to fix at 0, so it's going to be 4. Menu, Geometry, Measurement of the length from E to F, and you notice it's 4. And then you go to Menu, Geometry, Measurement of the length, and it's going to be from D to F, and you notice it is 5. So you notice that it's a 4, this distance is 4 units, this distance is 4 units, and this distance is 5. So you have two sides that are congruent. So this is an isosceles triangle. So I recommend that you have your Inspire calculator available, and we're going to kind of graph this rhombus, but we want to prove that it's a rhombus. So what I'm going to do is I'm going to go to Escape, Doc, File, nope, and I'm going to do Geometry, And once again, I have to go to Menu, Actions, and I want to see the grid. So View, Graphing. So there's a grid. I would say go to Geometry, go to the settings. I would say Fix 0, Auto, Degree, Dot. Okay, so I'm going to go OK. So we're going to graph A. So this is actually, it appears to be -2. So you're going to make a quadrilateral. So go to Menu, Geometry, Shapes. It is what you're going to have to do is we're going to have to do graph these lines here. So we're going to say segment. So we're going to graph from -2. Yeah, that's -2, 0. -2, 0 to -1. It goes up. Goes up 1, 2, 3, 4. It appears it goes up 4. So 1, 1, 2, 3, 4. Okay. So now what we need to do is we need to graph D, which is 2. It appears to be 2, 1. So I'm going to go 2, 1. So we go from here to 2, 1. We're going to graph from B to C, which it appears to be 3, 5. So it goes from 1, 2, 3, 1, 2, 3, 4, 5. And then you're going to graph from this point, what appears to be 2, to 3, 5. Okay, so there's our quadrilateral. Now we're going to construct the diagonals, then we're going to go from here. Oh, okay. So you want to escape, go from here to here, and then from here to here. So there's our diagonals. So it says use a slope formula to verify that opposite sides are parallel. But before we go on, what I'm going to do is I'm going to name that point, that's A. I'm going to name that point, that's B. I'm going to name that point, that's C. And I'm going to name this point, which is D. Okay. So it says here, step 1, use the slope formula to verify that the opposite sides are parallel. Remember, we want to find the slope from A to B. So let me tell you how to find the slope. Go to Menu, Geometry, Measurement, Slope. So let me repeat again. You go to Geometry, Measurement, and then Slope. And you want to find the slope of this segment. So you're going to write the slope right here. So it's saying the slope is 4. So if these two lines are parallel, then they have to have the same slope of 4. So here's a segment, and here's a slope. Oh, the slope is the same. So that means that these two segments are parallel. So now I got to figure out the slope of this segment, which in this case, it's the slope is 3 times 10 to the negative. Well, I'm going to go ahead and just write that there. You notice we have that E value. Ignore the E value for right now. But you notice that these two segments, the slopes are the same, so they are parallel. So we've kind of proven that this is a parallelogram. And now, to verify that it's a rhombus, to verify it's a rhombus, that we need to figure out the slope of this segment. And the slope is -1, and then we have E times 10 to the 0. And then we need to find the slope of this segment. And we know that the slope is 1. So the slope here is -1. The slope here is 1. So that's opposite. Reciprocal. So that, yes, it is a parallelogram and it is a rhombus because the slopes are perpendicular. We have here a parallelogram, and we're going to go ahead and construct, or we're going to go ahead and graph these ordered pairs. So we have 0, 1. We have -1, 4. We have 2, 5. And we have 3, 2. So let's go ahead and let's construct this figure. We know that this is M. We know that this is -1, 4. This is N. And we know that this is 2, 5, which is P. And 3, 2, this is Q. We're going to prove that this quadrilateral is a rectangle, but it appears to be a square. We know that if it's a square, then we know it's a rectangle. But let's investigate. We're going to use our TI Inspire to investigate. So I'd like for all of you to go to your geometry app, and you notice you have this. So what you're going to do, go to Menu, View. You go to View. Go to graphing, and you see the graph here. Okay, so let's go ahead and graph these ordered pairs here. What I recommend you do, let's construct segments. So we're going to go to geometry, and we're going to construct segments. So the first one is the first segment is MN. So we know it's 0, 1. It goes from 0, 1 to -1, 4. So that's -1, 2, 3, 4. Okay, that's the next one is going to be from N to P. So that's 2, 5. So we have this point, and then we're going to go 2, 1, 2, 3, 4, 5. Wait, that's 2, 1, 2, 3, 4, 5. The next segment is M to Q. So we go from M to Q is 3, 2. So it's 1, 2, 3, up 2. And then we're gonna go from Q to P. Okay. So let's go ahead and let's label our points. So this one is going to be, this is M. Okay, so this is Q. This is P. And you notice I'm using the shift button. And this is N. So shift N. Okay, so we probably want to make sure that there's a parallelogram. So we got to make sure that these two lines are parallel. How do we know they're parallel? That's correct. They have to have the same slope. So let me go ahead and go to Control, Menu, Geometry. And I'm going to find the slope. So I'm going to put the slopes here. So this is the slope of M to N. And this is the slope from P to Q. You notice they're the same slope. There's the slope from N to P, and you notice this is the slope from N to P, and they have the same slope. So this is a parallelogram. Now, I don't want this, but okay. So let me. Now you notice I have a 0.333 here, 0.333. That's the same slope. I changed the precision. It was going to 6 digits, so I changed it. And you notice these are opposite because the reciprocal of 3 is 1/3. It's negative. So these are all perpendicular. In other words, this segment is perpendicular to this segment. This segment is perpendicular to this segment. Now, what I want to do is I suspect that these segments are all, they're congruent. So what I'm going to do is I'm going to go to the menu, geometry, measurement, the length. I'm going to measure the length from here to here. That's 3. 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 Okay, so they're all 3. So I notice that these segments are all congruent. I also notice that the slopes are the same, so it is a parallelogram, and they are reciprocal, opposite reciprocal. So this is going to be these lines are going to be perpendicular. So this is a square. By definition, if it's a square, then it's also a rectangle.